Now let's continue with our calculation for the what do you call this Mochi factor. Take note, if you remember, we have our stiffness matrix minus omega squared as the mass matrix. So this is its form. We have 6,439.978 minus b, and then the other values. If you can see that there is a b there, a value apart. Now what we'll do with this is that since we have our roots for the b, we have the b1, b2, and as well as the b3, we just substitute these values for from this given or from our calculated or simplified matrix from taken from the stiffness matrix minus omega squared times the mass matrix. Now, if we employ b1 in our given matrix there, we'll have this matrix as a result if our b is equal to 1115.211. So that is just that is just 6,300 439.978 minus the b 1,115. The result will be 5,324.767. And for this part here, we have the 9,428.39 minus 0.5. This b1 there will give us this result, this value, and as well the this part here will give us this value. Now for our B2, which is 9,833.654, and as well for the B3, 35,024.479, we'll have the matrices as shown here and also there for the B2 and the B3. Now we have three B's, we have three roots for our B, and then we have the three natural frequencies and the three time periods. Therefore, we have also three matrices in order to solve the mode shape factor. So this one is for calculating the mode shape 1. Let's say that is the mode shape 1. We'll use this for calculation of the mode shape factors for the mode shape 1. And then this one for the mode shape 2. And this one for the mode shape 3. Okay, then let's start calculating the mode shape factors for the story. Let's start with the mode shape 1. Now, in order to calculate or to solve the mode shape factors, we need to make this in this form. We have the stiffness matrix minus the omega squared times the mass matrix. And we have our mode shape vector is equal to the null vector. So for the mode shape 1, if you remember our calculated stiffness matrix minus omega squared times the mass matrix from B1 is equal to this matrix as what we have calculated in the previous slide, this one here. And then our mode shape vector, that is mode shape 1 for the first floor, mode shape 1 for the second floor, and mode shape 1 for the third floor is equal to the null vector. Now, how are we going to solve this one? If you remember, we have a given mode shape. The mode shape of the second floor is equal to 1.0. So sa tupad, the mode shape of the second floor is equal to 1.0. Now, in order to solve the mode shape 1 and mode shape 3, we'll use the equation that we can form with a least number of unknowns or variable. So that would be the first row and the third row. So if you'll use the first row, you'll have 5,324.767, and then times this one here, the phi 1 or the mode shape 1 for the first floor, plus negative 4,259.245. That's the mode shape factor for the second floor, that is 1.0. So if you can notice that the operation here is row times the column of the mode shape factor, plus a 0, because this one, that is 0, times mode shape 1 for the third floor is equal to 0. And since this is already equal to 0, we are only left with one unknown, the phi 11 or the mode shape 1 for the first floor. So let's just simplify this. We'll have 5,324.767 phi 11 minus 4,259.245 is equal to 0, or 5,324.767 P11 is equal to 4,259.245. And from there, we'll be able to calculate our mode shape 1 for the first floor. And that is equal to 0.8. So, diba? As you can see that this is just quite simple when you just follow the step and you understand everything. Next is, what will be the next? Since we have already our phi 12 and our phi 11, our next value to be calculated will be this one, the mode shape factor for the third floor. We'll be using this third row here, the third row that is equal to, let me write it here, we have 0 times phi 11 plus a negative 5,169.146 times 1.0 plus the 4,890.343 times the phi 13 is equal to 0. Same thing, you just simplify this out. We have 4,890. If we write the whole uh, equation, we have the negative 5,169.146 plus 4,890.343 P13 is equal to 0. Then we're left with 4,890.343 P13 is equal to positive 5,169.146. Now we'll be able to calculate our mode shape 1 for the third floor is equal to 1.057. Now this is just similar with the calculation for the mode shape factor for the other mode shapes, for the mode shape 2 and for the mode shape 3. Same thing with what we did from the mode shape 1. The same thing also for the mode shape 2 and for the mode shape 3. So this is our calculated, as you can see, the operation is still the same. We have the stiffness matrix minus omega squared times the mass matrix, and we have our mode shape vector is equal to the null vector. So here we have our mode shape 2 for the first floor and for the third floor, and as well here we have the mode shape 3, mode shape 3 for the first floor and mode shape 3 for the third floor. With the same operation and with the same process, from the first row here, from our mode shape 2 matrix, we'll be able to calculate that our mode shape 2 for the first floor is equal to negative 1.255. And from the third row, we'll be able to calculate our mode shape 2 for the third floor is equal to 1.907. Same also with our mode shape 3. From the first row, we'll be able to calculate the mode shape 3 for the first floor is equal to negative 1.441. And from the third row, be able to calculate that our mode shape 2 for the third floor, sorry, mode shape 3 rather for the third floor, for the phi 33 is equal to negative 0.149. Okay, we'll just take note of these values. We already have our mode shape factors. Then we'll be able to sketch now the mode shapes per uh, roots or the per frequencies that we have. Okay, we have here, let's draw our mode shape. Say this will be our mode shape 1 here. And then we have the mode shape 2, shape 2, mode shape 3, and the total mode shape. Again, there's the mode shape 1 for the third floor. That is 1.057. Mode shape 1 for the second floor is equal to 1.0. This is for all mode shapes. And mode shape 1 for the first floor is equal to 0.8. Now the mode shape 2 for the third floor is equal to negative, no, that is not negative, but a positive 1.907. And then for the second floor, mode shape 2 for the second floor, again, that is 1.0. And the mode shape 2 for the first floor, that is equal to negative 1.255. Mode shape 3 for the third floor is equal to negative 1.441. Mode shape 3 for the second floor is 1.0. And mode shape 3 for the first floor is equal to negative 0.149. So now let's start sketching our mode shapes. So here we have our lamp mass model sa atoang structural system. Now let's start sketching the mode shape. So let's say for the second floor, for all second floor, we have 1.0 and that is positive, and then let's say the positive is to the right. So therefore, our mode shape for the second floor will look like that one. For the mode shape 1, our third floor is 1.057. So that means it's just past the shape of the second floor. So that will be around there. And for the first floor, that is 0.8. So that is within 1. So the mode shape 1 there for the first floor is will look like that. Now, you just draw the elastic curve. And now we have the mode shape 1 for our third, for our three-story MDOF system. So here we have our 1.0 and then our 1.057 and our 0.8. Now let's proceed with our second mode shape. So for the second floor again, that is 1. Our topmost floor is positive 1.907. So that is almost twice the shape of the second floor. Yes. So let's say that is here over here. And for the first floor, we have negative 1.255. So that is past the mode shape of our second floor. Pero since negative, so it means that will be on the other side. So let's say it is here. And then we'll just draw the elastic curve of the mode shape. So this will be our second floor. So the topmost, we have the 1.907. And then here we have the 1.0. And here we have the negative 1.255. Then lastly, for our mode shape 3, we have for the second floor, again, that is at 1.0. And for our topmost floor, that is negative 1.441. So say around here is negative 1.441. And then For the first floor, we have negative 0.149. So let's say that is around there. That is negative 0.149. And then let's draw the elastic curve. And eventually there. If you notice, no, if we let the root 1 as our lowest value or our lowest frequency, we call this our fundamental frequency, the lowest frequency. And if you can notice, its mode shape is that all the floor is on the one direction. And then for our second mode shape, the two floors is on one direction while the other one is on the other direction. And then on our mode shape 3, each floor is on differing direction with the preceding floor. Now, let's get our total mode shape. The total mode shape is just the average of these three. So you just add the values there, and then we'll be able to get our total mode shape. So for the mode shape, the total mode shape for the third floor, we will also have our total mode shape for the second floor and the total mode shape for the first floor. For the second floor, that is just 3, 1, and then the average of that will still be at 1.0. For the topmost floor, we have 0.508, and for the first floor, we have negative 0.201. With the same lamp mass model, the total mode shape for this one, say this is the 1.0. So our topmost is past half, a bit past half of the second floor, that is 0.508. And for the first floor, that is around there at negative 0.201. And then let's just draw the elastic curve, their columns. Okay, that one. Okay, so that is just how you solve the mode shape of the MDOF system. So just for the summary, now you need to have your stiffness matrix and as well your mass matrix. And afterwards, you get this difference of the stiffness matrix minus the square of the natural frequencies times the mass matrix. And then you'll be able to solve the stiffness or the natural frequency by getting the determinant of that simplified matrix is equal to 0. And then afterwards, you'll be able to calculate the mode shape factor by using this equation that we have the stiffness matrix minus omega squared times the mass matrix times the mode shape vector is equal to the null vector. And eventually, you'll just catch the mode shape of the system.